Okay, welcome to this presentation of continuous delivery pipeline in Google Cloud with Kubernetes and Jenkins. We start right away with some demo. So let's leave the presentation. So first of all, we need a cluster, a set of machines to deploy our application in. So we go to Google Console. So this is the Google Cloud console in the web. We have a menu on the left here with all the services available in Google Cloud. And for this presentation, we will use the Kubernetes engine service. So we need a new cluster. There is already one, but that is something else, as you see. So let's create a new one. We give it a name. And we place it in Europe. Mostly default values for the cluster. It's a set of 3 machines. We will add, give it permission to all cloud APIs. And then we create it. This will take a few minutes, so let's continue with some slides. Okay, Playtech BGT Sports, PBS. We are, as Andreas said, building sports betting applications. In Malmö, we are responsible for the web client parts. We are always getting sports data from some external API. This is the API on the right here. And apart from sports data, we also do transactional operations, login and place bet and so on to that API. We have a few server-side components in Malmö that we are responsible for. First of all, we have a content service, and this content service is consuming sports data from the API. Most of the time, this data is not optimally structured for web clients. So that's what we're doing here in the content service. We restructure the sports data and we cache it in a MongoDB NoSQL database. We also use a Redis database pub/sub solution to notify changes for anything that changes in the MongoDB database. At the front end, we have endpoint services, and this is what connects to the web clients. We are serving static files, HTML, CSS, JavaScript, and so on. REST API endpoints for transactional operations, and also serving the data from our database over WebSockets. So this is our application for the web clients. And running that locally, we simply go in the code base and do Gradle build to compile and bundle our application. Then we start a local MongoDB, start a local Redis, and then start up to jar files, Java files. This will not be enough for the cloud. So how do we do this in the cloud? We have selected to go for something called Kubernetes. And Kubernetes is an open source solution supported by many cloud vendors, so that sounds like a good way to go. Kubernetes, however, has a contract for how you add your applications to Kubernetes, and that contract is Docker. So you need to provide your application in Docker containers to be able to run them in Kubernetes. So that's what we're going to do. We have our jars, Java jars. We have MongoDB and we have Redis, and we have to provide them to our Kubernetes cluster using Docker. I will not go into deep detail about Kubernetes and Docker because I have explained it once before at Foo Café. Check it out on YouTube. I will focus mainly on continuous deployment using those technologies. And for that, I guess you are all aware of this guy, world's most famous software butler, Jenkins. And in his hand, he has Kubernetes and a Kubernetes plugin to work with the Kubernetes cluster. Okay, so hopefully we have our cluster ready. It doesn't seem like we do. I will talk about what we need to install here. So we need to install a few services that we use for our setup of continuous delivery. We need nginx, Jenkins, and external DNS. And there is actually already a load balancer in Google Cloud, but it did not really suit our needs for routing traffic in the way we wanted to. So instead, we went to Kubernetes at GitHub. They have an nginx, Kubernetes adapted nginx load balancer. It suited our needs better, so this is what we will install. There is deployment instructions here, and we simply follow them without really making any changes. We also need Jenkins, of course, because we're gonna set that up. And then there is a site called kubeapps.com. Easiest way to deploy applications in your Kubernetes cluster. So here you have shareable applications, and we can search for Jenkins here, and then you follow the instructions here to set up your Jenkins, and it can be as easy as running this command. There's also one third service we want to install here. We want to install something called external DNS. So external DNS, if we go to its website, synchronizes exposed Kubernetes services and ingresses with DNS providers. So it's quite an awesome tool that lets you deploy this service to your cluster and dynamically generate host names for when you deploy applications to different branches or from different pull requests, and you get dynamically created host names. So you don't have to mess around with IPs and remember that. So those are the services, and let's see if we're lucky. Yes, our cluster is there, Foo Café. So let's connect to it. Here's a command to connect to the cluster locally. We paste it there. And now we're connected. And then I will run my commands. I have them in a make file. So let's start with nginx. We make sure we're connected to the cluster, and then we apply all those Kubernetes configuration files that we downloaded from the nginx ingress website. I will not go into detail about what's in it because I haven't modified any of the files. I just deploy what was there. Then we need to run something called helm init, and helm is what is required from this kubeapps site to install those shareable installations. And it's a really powerful tool. It's called the package manager for Kubernetes. Now we're ready to install Jenkins. So it's a helm install command down there, and it will be deployed directly with a bunch of deployments and services and configurations. But this is the command I've copied from the kubeapps site with just some minor modification on configuration flags. Finally, we had one more, and that was external DNS. Again, taken from kubeapps, just install it. So they have been deployed, but it takes some time for it to get up and ready. I think we can start to look at our code now. Is that big enough for you? You can read it? Great. So this is the source code for our sportsbook product for volume customers, a bit modified to make it work within the minutes I have here for the presentation today. So let's look at the client first. So here we see that the client is already ready to be served. It's already bundled, transpiled, and so on. So we're ready to serve the client. What we have here, apart from HTML and JS and CSS files, is a Docker file. We need a Docker file to create a Docker image, and our Docker image will be based on the official nginx image, where we simply copy in our client static files to the default nginx HTML folder, and that's enough to serve the static files that we want to serve. And don't this is not the same as the nginx I installed before. The other one will be used as a load balancer for all traffic to the cluster. This one is only a way to serve static files for this Docker container. Moving on to our server-side components, we have a content server with some Java code. We have endpoint server, and we're building this stuff with Gradle. So let's look at the Docker file for that. We're basing our Docker image on OpenJDK Docker image. We will copy in our source code. Then inside it we will run Gradle build to compile and bundle it. Then we will go into the build folder, and there we will set the default command to be java-jar for the jar file. So now we have containers for our servers and for our client. So how do we connect this to Jenkins? How do we build and deploy this with Jenkins? We have decided to use the Jenkins pipeline, where you define your entire job in code, instead of having to click around in the Jenkins UI to fill in what parts should be built and how to deploy, etc. So let's build this one up. You define your Jenkins job with Groovy language. And the first thing we need is a node scope. A node is where you allocate a build agent. So typically you should run everything inside the node scope, because you don't want to put pressure on the Jenkins master showing the UI, etc. Inside here we will have some stages. This is only for UI in the Jenkins UI to present to the user of Jenkins to show which part of the job you're currently working in. So we need to check out the code, build Docker images, and deploy applications. So let's start with checking out the code. So this Jenkins file we're building up here will be added to the Jenkins UI later on. So that is the connection between Jenkins and the Jenkins file. There's a GitHub connection to this file. So what we will do here is that we will run, I will move these up here actually, no, that one. We will run the Jenkins command checkout with the parameter SEM. So SEM is a parameter that's available that holds the information about the Git repository, and checkout will check out the entire Git repository. So after this line we have everything checked out, and we have a map of some variables that we can use later on. We need the branch, and we want to have the commit ID for the current commit. Checked out the code, so now we're ready to build. And this is how we will build it. First of all, we will define our Docker image registry, and it will be the Google Cloud Registry in Europe for our Google Cloud project, which is named Mobenga System Architects. And then we have a sub-project named called Foo Café. Then we run this gcloud command here with the image registry, and append the unique identifier for our server, and also add the commit ID, so we can create unique Docker images for each time we push to GitHub. Finally, it's the folder of where we have our Docker file. As you remember before, I have Docker files, one in client and one in servers. This command here, gcloud container build submit, could be replaced with Docker build. If you run it locally, then it will be the same thing. This will result in running in a Google Cloud service that has Docker builders off the shelf, and will also automatically publish these Docker images. So it saves a bit of time. So deploying in Kubernetes, there's a concept called namespaces, and we want to have namespaces because otherwise you have to think about every service you deploy to a cluster, they have to be globally unique. But if you deploy something to a namespace, you only have to be unique in that small namespace. So every new deployment you make for a different branch or for a different application, it's recommended to use a unique namespace. Now we use the helm command again, as you saw when was the same one I used when installing Jenkins and external DNS. Helm upgrade install. So if it's not already there, install it, otherwise upgrade the current deployment. We set the namespace, and then we can provide some variables to this helm command. We provide commit to the commit ID. We also set the helm installation name to what the namespace is. So the helm installation name will be Foo Sports Develop, because we are in the develop branch. Finally, the folder of all our Kubernetes deployment configuration files. And let's go into that folder. As I said, I will not go too much into detail on how Kubernetes works, but these are our Kubernetes deployment files. So let's look at some of them. For the endpoint server, the important part here for the deployment of the endpoint server is the image here. So here is where we see the image for our endpoint server. And here's a template value here with the commit, which I provided at the helm upgrade install command. So this is only possible if you deploy using the helm command instead of using kubectl, the raw command. Every deployment that you want to expose to some other Docker container or out to the world, you need to have a service connected to it. So this service will expose this deployment and connect the internal port to some external port. Similarly for MongoDB, except for that the image here we don't create. This is an official MongoDB image, so we don't build that ourselves. So this is a simpler image name. Redis, same thing, different ports of course. Static server, that's what we build ourselves. Different ports here because the nginx default port is 80 and not port 8080. And now you might see that we don't have the content server here. And I decided to not include the content server for this presentation because it takes some time to populate MongoDB from the betting API, and we don't have time for that when we run through our continuous delivery here today. So instead, I took a snapshot of MongoDB, took a snapshot of this deployment when I ran it in our demo environment, and then I run a Kubernetes job here instead. Kubernetes job where I have pre-built an image with this MongoDB data, and when it's run, it will run once and populate the MongoDB database with the latest sports data from yesterday. So that's almost everything. I forgot the ingress. Now I have also almost gone into detail about Kubernetes, but let's do that anyway. So an ingress is instructions to the load balancer on how to route traffic. And our load balancer, as I installed before with to the cluster, is nginx. That's our load balancer. And we can set some annotations here, sticky sessions, for instance, here. Extend the read and send timeouts to a bigger value because we're using WebSockets with an open connection to the client. And then finally, we set up some rules here on how the traffic should be routed. So any incoming traffic to the load balancer that matches this host here will be forwarded to the static server service. Unless it's on /API, then it will be forwarded to the endpoint server. And we do it like this because the client calls /API for sports data, and everything else like static files and so on goes to /. Release name here will be the name of what I had here. So that will be replaced to Foo Sports with a branch. So Foo Sports Develop, for instance. So these are the instructions for Jenkins. So let's commit that. Commit it to Git. And then we push it to our GitHub repository. And now it's pushed. Okay, so you saw this something else cluster before, and I didn't want to take the risk with anything of the Foo Café cluster, so I already did the installations I did before on Foo Café on this one earlier today and pre-tested it to make sure it works. So that's the one holding a Jenkins installation as well. So if we go to Jenkins here, there's a Jenkins on the Foo Café cluster, there's a Jenkins on something else, but I will use this one because I have pre-tested it before. So as an empty installation of Jenkins with, of course, the Kubernetes plugin installed to it, and also connection to GitHub. So let's create a job here. Sports Foo. And we use pipeline. Pipeline is when you use this Jenkins file of having your configuration in code. So multi-branch pipeline will detect all your branches. You can use a single pipeline and point out a specific branch, but I will use multi-branch pipeline. Now we connect it to our source. I have pre-filled credentials, so you don't copy my password. So Mubenga is everywhere. That was our previous company name, if you wonder. And then we take the repository I have forked to my own user from our main repository. So that's all the configuration you have to do in Jenkins, which is quite nice. So you only connect it to your repository and it will start to search through all the branches for this Jenkins file. And now we see that a Jenkins file is found in the branch develop and nothing else. It also looks for pull requests and see if there's a Jenkins there. Let's go back. Now we see that there's a branch created, a job project for the branch created, and a job has started here. So now it's checking out the code. This is one of the stages I had in the Jenkins file. Let's move this one out here. Let's see if I can do this. So we can have a look at that one. Jenkins file done. Set up Jenkins job. Okay, Kubernetes. I just want to explain this one again. There are services multiple places. So we have our content service and we have our endpoint service. Those are the Docker containers, and when they run in Kubernetes, they are running as pods. That's what they call it in Kubernetes. So we have 3 pods. Actually, there should be a MongoDB here, but it's left out for simplicity. To communicate between pods, you cannot communicate directly. So you need to have a Kubernetes service. So for the Redis pod, we define the service that connects to the Redis pod. And then if anyone wants to communicate with this one, they have to communicate through that service. So no one can communicate with this one, no one can communicate with this one because they don't have any services connected. One benefit of why they do this Kubernetes is that you can scale this up. For instance, you can scale it up to 100 or so, and the other pods don't have to care about if it's one or many, usually, as long as this container supports it. So that's services. There are a lot more concepts in Kubernetes, but this is quite important to grasp. Let's see how the job is doing. It's building Docker images. Okay. One thing I can show you that I did that is nice to do as well. As you saw, no, I actually didn't show it. So we can go into GitHub. No. So that's the repository on GitHub. And if we go into settings, I recommend you to add a webhook for your Jenkins server. So right now it's only running on an IP, but you get the idea. You add a webhook here, fill in the password, and then you paste in the webhook URL for your Jenkins, and then you will be automatically notified when something changes in GitHub, and the job will start automatically. But as you saw, I had already set this up for this Jenkins. So the job is ready. We can go into the job, look at the log. There should be a host name here somewhere. So there we go. The sports data is yet not populated. There we go. There it is. I think we should remove this one. So this is our example sportsbook, not connected to a specific customer. But now we're up and running, and as you see, we have our unique host name for this one. And I think we have time left. Yeah. So let's create a branch and push a change and see that we can get a unique host name for that one as well. So I will make a change. Let's see. We have a text here. Your bet slip is empty. Let's change that one. Continuous delivery in the cloud. Sounds like a smart change. Okay. We need a new branch, so create a new Git branch. Bet slip change. And there's the change, and then we can commit it. So we changed this language file from your bet slip is empty to continuous delivery, updated bet slip text, committed, and pushed to a new branch. It's pushed. So let's go to the root of our project, Sports Foo, and you see that it's listing another branch here. Bet slip, first job is running. Push event to branch bet slip, so that's a push event from GitHub. We can look at changes, maybe that's later when it's done. And we see that it's been started. While it's working, this one, let's do this trick again. While we're waiting, I thought we could talk a bit about why we started with this continuous delivery in the cloud. So there are a couple of things that has been blocking development from an operations point of view or DevOps point of view, and I will show you some scenarios here. This represents a development team. This represents ops or DevOps. So traditionally in our company, the team is requiring we want to test more features at the same time. We want more environments, so we can test this feature, but we also want to test this feature. And then DevOps has to buy new machines and install Java on it or whatever to get it up and running. With this new continuous delivery pipeline, it's as easy as creating a pull request or creating a new branch, as you hopefully soon will see here, and you get your machines up and running. Next scenario, we need more build agents. Happens every now and then that all our, 6 or 7 old build agents for our local build server are full, and teams have to wait to get their features out, or even worse, deploy out to production because there's no agent ready. And then again, DevOps has to buy machines if it's a big problem. Maybe buy licenses if you're using that sort of build server where you need more licenses for more agents. But now Jenkins and Kubernetes is helping us to produce builder bobs. So if 100 people, 100 teams want to build at the same time or 100 features, we get 100 builder bobs. Of course, you can set a limit in Google Cloud, but you have auto-scaling both on Kubernetes level and on machine level in Google Cloud. Another nice thing is that usually no one is building in the weekends, so we can scale down our build machines to 0 during the weekend. Third scenario, okay, everything is working, but now we need a new technology, both in the environment and the build servers. Again, there's a team of 2 or 3 people that has to manage all this. Now we move the freedom to the development team. They are responsible for themselves to maintain their Docker images. If they want to have Java 9, they just change their base Java image to Java 9. And of course, they are responsible for making sure it works still. This is not something a central organization like operations should own. So that's the 3 biggest scenarios I think we have come around with this new way of doing continuous delivery. And our build is ready. Let's look at the log. We have a new hostname. There we go. It works. I think that was, did I have some slides left here? Yeah, let's just show this one quickly. A few things that we also have implemented that I will not show here today. Test automation, of course, at the end of your Jenkins file, do a run Selenium test or whatever to that URL that you just got created. That's what we've started doing as well. Shared libraries, a lot of Jenkins file everywhere with the duplicated code. So there's a nice support in Jenkins to create shared libraries where you can use shared functions to minify code duplication in your organization. Deploy to other clusters is nothing strange. Just set up the right permissions between clusters and projects, and that will work more or less out of the box in Google Cloud. So we have separate clusters for production and for development, for instance. Delete namespace on closed pull requests. So we are running new environments on new pull requests, all our teams. And when a pull request is merged to main branch, that environment should be closed down automatically. So that there we have a central job that detects webhooks from GitHub and closes the matching release or namespace. GitHub authentication in Jenkins. On this presentation now I only logged in with the default Jenkins user, but there's a GitHub authentication plugin for Jenkins, so you can connect it to your GitHub organization, and then everyone has access out of the box if you're using GitHub. There's a new UI in Jenkins called Blue Ocean. Nice to look at, nice to get an overview after your build, but doesn't have all the features. So if you want to go into the console or replace some part of your build chain, you have to go back to the standard UI. But have a look at that one, it's quite nice as well. And detect changes to not rebuild everything. If you're only changing client code, you can detect that you only change the client, so you only update the client Docker image. That's also possible. Hint, hint, if you think this seems fun. And thank you for your time.